we are measuring the cement right now. That's 5,514 grams. So we are bringing this to 0 again, and now we'll measure 6,600 grams of fly ash. So we have measured 6,620 grams of fly ash, and now again I am setting it to 0.
So I'm going to measure the sand. It's 4,415 grams. And do at the first like this, but at the end more accurate. So basically we need to perform 4 plates, 3 cubes and 2 beams. That's why we need that amount of materials. 4,415.
Yeah, so now we are measuring 259.6 grams of fiber.
So now we are going to measure the amount of water, which is 3,517.9 grams. Technically, we are keeping the water to cement ratio, which is the most important part of ECC, to 29% here in the mixing sheet. So I've already measured 3,000 grams. I'm going to add more 500. I've measured almost 3,518 grams of water. And I'm going to keep it just this. And now we are going to measure the HRWRA as a admixture, which is 73.4 grams. This will make the mixture more flowable. So 73.3 grams and just one more drop. You can stop.
So we are oiling the molds right now, and this will prevent the concrete after it has settled from sticking to the surface of the molds, so that we can easily remove the molds from the concrete parts.
The These molds are for beams. These ones are cubes for doing the compression test, and this one is for plates for doing the tension test with MTS machine.
Let me know when the time is up on the clock. I think it will start by itself. Stop by itself. So there is no force aggregate as I mentioned before in this mixer. So these are what are called the high shear mixers. So you guys can come closer here if you want to look at it. So high shear because this pedal can generate a lot of shearing force, and that is needed when you show them the fibers, the loose fibers that we'll add to them. So you can actually touch and feel these fibers. So these are just like your hair, right? Same diameter. So these are polyvinyl alcohol fibers.
These are bundled fibers.
So these are all bundled together at this stage, right? But you need the high shear of the mixer to separate them. So the high shear of the mixer is needed to separate them. You cannot do this in conventional concrete mixers.
Are you going to add that before adding water?
No, after. Okay, so the dry part is all mixed and ready to go. So now go ahead and add all the water in it. Plasticizer we'll add later, depending on how much we need. Okay, so set it to about 5 minutes even. Yep. And then slowly add water to it. No?
Do we need to close that thing?
Oh, maybe yes. So safety thing maybe.
Then, yeah, but we
Let's try if we can do it from the side. Yeah. You can go a little faster otherwise, so that it gets wet faster. It doesn't fly. Not right now. We'll do it at the end.
That is the super plasticizer.
That is the super plasticizer, yes, correct. So in this, it is water-based material. So a lot of it is just water at the end.
Yeah, at the end.
Oh, okay. So you can come closer and have a look. How it looks like this stage.
Use a similar mixer for large batches.
Yeah, so it's a much larger version of this. So there are these giant paddles, they're much more stronger. The torque of the machine is much higher. And so like if you have to mix ductile material like these ultra high performance concrete, so you have mixers like these. Yeah, you cannot do it in the regular truck mixer. Those just don't have enough shear capacity to generate. Okay, all in. All right, so now we'll stop it and increase the speed a little bit here.
Plasticizer.
Yep. Now I'll add some super plasticizer. It's actually, yeah, let's stop that. Let's go slow. So they will see the miracle that happens when we add plasticizer.
You start?
Yeah, go ahead. So now see how thick it is, right? Now see. You will see the change. And it is nothing compared to the amount of water we added, right? We added the whole whole of that as
I
water.
added water
You just
to the,
small amount.
You added water to that too?
yeah, because it's too thick. I added some water to that to make it easier to add.
Oh, okay.
The original amount was like this.
So you see, already it has fluid now, right? And we need even a little more fluid than that so that the fibers can be accepted in that easily. So let's stop that. Now increase the speed.
You just go by eye? How do you know when that's mixed?
So there is a certain, so you can measure the viscosity of it, but now, I mean, with experience, I can tell it just by looking at the mixer. So how much runny it is. So it should not be too runny and it should not be too thick, because the mixer has to actually shear out all these clumps of fibers by itself with this shearing action. And it has to separate all these clumps into individual fibers, and it does that. So if it is too fluid, then it won't be able to do it, or if it is too thick, it won't be able to do it. Just have to the optimum amount of viscosity.
Is that paddle this typical paddle that we use for bread dough, or is that
Bread dough, yeah. That is it. That's
That
it.
is it.
Yeah, it's a bread dough mixer.
Yeah, but the paddle itself, that's exactly the
Yeah,
same
that is
too?
exactly the same.
And that will break all these up.
Right. So it is still thick, a bit thick. That's why I stopped and looked. Add a little more here. Again, stop. Increase the speed. So see, now it's almost very fluid, right? So, have you seen a concrete like this before? So we need this much amount of runniness so that it allows the addition of fibers. Otherwise, if it's so thick, you cannot disperse the fibers properly in this mix. And you will see, so these fibers are actually hydrophilic in nature. So as soon as you put them in the mix, they will actually absorb a lot of water on their surface. They will withdraw a lot of water which has gone into the mix. So it won't be as runny as you are seeing it right now. It will be much less runnier. Okay, stop it, and let's do that test. Do you have the trowel? So a simple test is to, if you don't want to do the viscosity test, you just take a trowel like this and see if it has a continuous flow like that. Okay, so it should not break up into different pieces when it falls down. So this is a good runniness. So you just have to be at the threshold between complete runniness like water and a semi-solid paste. So it has to be somewhere in between, and I think this one looks good. Can you lower that? Make sure that there is nothing at the bottom of the mixer. Yeah, just scrape the bottom of that mixer. I will switch it off.
Got it.
I think, do we need some more plasticizer, you think?
That looks okay.
Okay. There's nothing at the bottom?
Nothing at the bottom.
No dry stuff?
No.
Okay. So we need to check because there is some clearance between the bottom of the pedal and the bottom of the mixer. So if there is some dry stuff there, it would never be mixed because it is at the center of the pedal, right? So it should not stay there. Okay. All right. And put it aside in that large tray over there. We can wash it later. Alright, so is the time okay over here? We'll reduce the speed and start it. Alright, so I will add a little more plasticizer to it. Now you can simultaneously start adding fibers.
Over here?
Yeah. Maybe use that one, the scoop.
So you predetermine how much superplasticizer goes in there, right?
Yeah, so
Will you
but this is
eventually-
our first time using this mixer as well. We have been working on the smaller one. So the plasticizer, we have started off with that amount, but then a larger mixer needs slightly smaller super plasticizer amount because it has a lot of forces in it. It is bigger machine, so it can generate more shear.
So you might not use all of it.
Might not use all of that, yeah. So we'll see, but that is like an upper bound. It definitely needs smaller than that amount. So,
Okay.
yeah. You can, yeah, go as quickly as you can. So see, already you can see the start to see the change in consistency is becoming less runnier as the fiber goes in. I mean, it is still quite flowable in nature.
Is there any risk of over mixing it? Going it too long or too fast?
Well, not really. I mean, you can go a little faster than this. I mean, I'm just doing it that slow so that we can capture it very well. The change between no fiber and with fiber. Yeah, the rate of addition of fiber should not be like right away. It should be like within 1 or 2 minutes you can add all the fibers. Yeah. So you see the difference? Alright, so now we'll increase the speed here. We'll go for about 2.5 minutes or so. So why don't you guys wear a glove over there? I want you to feel it. Then we will pour it into these molds over here. Okay. Hamid, why don't you bring the mold over here?
Last time I don't want to make
Yeah, you can, well, for now. So typically the whole process takes about up to 15 minutes. And then another 10-15 minutes to make the mold. But you should be done within half an hour, because after that the cement really starts to set in. So do not delay longer than that, because we are not using any set retarders or anything like that in the concrete. All right. So I will unplug it over here. Safely see that. Let's see. So right now I am just trying to see if there is any clumping of fibers in it, which there is not. So that's a good news. We will take it out over here. Well, first you need to remove this. Yeah, that's enough. Put it over there in that tray. There. So just put it here. So now you can actually dig in and see how it feels. Like that. Okay. Go ahead. Don't have much time. Because to start to set.
Did you normally have a retarder in there?
No, I haven't put any retarder there, but you can, yeah, if you are doing it in the
No.
field.
It would not be unusual.
Yeah, it has been done before. All right, so if you're ready to go with the scoop, start placing it in. So maybe you want to set up over here. Over here.
Okay.
Yeah, that's good. So see, it has already separated all those clumpy fibers that you saw, right? Get the wire, we're going to switch on the vibrating table. So now instead of using a vibrating rod, the whole table will vibrate. self-consolidating concrete. But now, once you're done, remove that. Let's wait. Not amount of vibrating. Okay, now this one. Almost never done for normal concrete. Never done for
There's a regular ASTM test for that?
Not really. So this hasn't gone into ASTM yet, but there is a European and Japanese standard on it, which normally people use for this thing. So yeah, I think it is not much enough pushing into that yet for things to get standardized from ASTM. Europe and Japan. Yeah, let's do it.
Yeah, I was there and I just missed you.
Oh, okay. Yeah, the whole point was to come here and we can.
Yeah,
We got it.
I had to go look at
Yeah.
see who I missed a call from.
Right. Yeah, the center one is okay. Mostly for aesthetics rather than for any useful purpose, because we'll actually flip the cube and test it on the other two sides, which are definitely very flat. Okay? Because we have 5 other sides, right? We have 2 sets of perpendicular or parallel sides which we can test on. Fill it everywhere, so wherever the concrete stocks of cartridge come together, there is no fibers bridging that portion of cartridge. So you have to go either from one way to the other, one side to the other, or from center to the both sides. Yeah, it should be a continuous process. Oh, switch it on. Yeah, that's okay. So the amount of fiber that we add, it takes into account the variability in fiber distribution. I mean, that's just the nature of it. So we cannot make it perfect. So just needs a tad more. Yeah. Yep, that's good. That is all the concrete we need. That's all right, Jake. Take care of that. Yeah. Oh, that's no. Oh, this is not garbage. This is sand. They just covered it up. I got it. mixing and what is ECC. Are you guys free tomorrow in the afternoon? How about the same time? Okay. I mean, we'll be demolding the specimen tomorrow. So if you want to see that, and actually you can also do that.